BluntCut MetalWorks, May 2nd, 2021. I'm going to test edge stability and impact toughness for different steel. And this is part 2, where the part 1, my heat treat, was target for impact and shock resistance. Even though at a similar hardness, the use strength was lower, and so this one I trade in the shock and impact resistance, basically some ductility for much higher strength. And this is 16D. You set up, and this is going to be the quality check here. Make sure my setup is okay. And so I'm going to do basically 3, and so that get a quality check. And this thing, the nail have tendency to jump away from setup. Okay, first up is the little knife S30V 62 Rockwell. If you see from the previous video, some of the Rockwell stay the same and some Rockwell change because I did additional heat treating. So what I'm going to do is plan is going to do 3 cut and then record, and then look at the median damage. Also, I'm looking at what the damage mode going to be, whether it's fracture or it's deformation, for example. That is terrible hit. You can see I already tilt sideways. So that's just a poor hit. I have to redo it. I think this thing, because I got a little bit curved here. So you have to compare to be fair. So okay, more than 3 hit, but basically it's right there. Let me mark it. So that is okay. Are you going to do 3 consecutive hits because instead of rotate among them, because I think that getting used to the spine and the stroke. Two. Three. That is the S30V. Last time I had 1085, so this time I got 2063 here, 62 Rockwell. All the blades sharpened at 18 degrees precise. Anyway, and the heat treat is 725. That bad entry right there is an angle. So, redo. Okay, got it. So I X out the first shot. this Aebl, a 61 Rockwell. A lot easier to hit with a bigger, thicker spine. 1, 2, 3. Again, I will take a close-up look at the median damage edge. I mean, where the edge of damage is. And this is the Magnacut control heat treat. That means I use the manufacturer heat treat. And these are previous tests. I have little damages already. So I mean, I resharpen it, but however, you know, ignore the area of damage, early damage. So there are 3 lines. I'm going to use that 3 line to retest. Along the way, I might have to stop the video and then do if it's longer than 30 minutes, they will cut me off. So I'm going to if everything takes too long, I'm going to stop and then restart the video. 2. 3. This is a Magnacut heat treat Theta 2.5 here, and a 62 Rockwell. Oh, by the way, I noticed last time when I did additional process, it becomes 62 Rockwell now. Previous video was 61.5. Anyway, it's, as I just make sure that I did resharpen it or I didn't do it. Okay, I used the same 3 line that I did before. Three. This is CPM 3V, and probably got to mark the different 3 lines so that I don't 3 dots instead, so that I don't. 62 Rockwell. older blade now should be a lot higher use strength, so that it will deform a lot less than my previous test. Retreat 725. This is Magnacut 4E. Previous test with a 64 Rockwell, now a 63.5. This will be much stronger than the previous one. The previous one can handle impact and shock more. And this thing will have higher use strength. So, and the reason is, again, this is higher Rockwell than the many other ones, because I want to keep it at high Rockwell, because I think it's capable of supporting it. This is the Niolox, a 62 Rockwell. Last time the edge, it's so ductile, have so much shock resistant. It's unpleasant. But now we see, after I did additional process, trading ductility for strength. Lower carbide volume will be lower strength overall, because when the hard particle move and they power up and they resist the movement, so therefore a little higher strength. But anyway, so this Niolox is not very high carbide volume. This Elmax, a 62.5 Rockwell. Previous, this same blade, a 61 Rockwell. So now this thing is a lot higher. Strength now, and the Rockwell as well. Mark it. Hard to see with that one. There's hardly any marking. There you go. I've got the mark. Okay. That one, right? So I have to do another one next to it now. Elmax is highest carbide volume among all these blades, I think. Next will be the S30V, because they have Elmax at 1.7% of carbon. Alright, that tree. Just remember when I test, it's when the rest of the edge right there impact the aluminum block here, but that's okay. This is the overview of the edges, macro view, and the ruler tick mark here is 0.5 millimeter, or it's equivalent to 0.02 inch. And S30V, as you can see, relatively here, you see some deformation. And then the 26C3, you can see more deformation here. But it's not bigger than the, maybe the size of half a millimeter or something like that, right there. Aebl is 61, and they took also one have a little bigger damage, but again, I mean, that's why you do in the average. I mean, the median later on for the zoom in. This is the macro. I'm not sure what the magnification is. Anyway, and you can see that the lower the carbide volume, then you know the use strength is going to be lower than the one with higher carbide volume. But the important thing is looking at the damage mode. Make sure that so far they all these things so that you have by deforming, and so for plastic deformation rather than fracture, you know, or chip. You know, there's no chip here. The Magnacut, the 62 Rockwell. This is the control on the manufacturer heat treat, and you can see the tree cut right there, the nail mark, and it's a very minimal. It seems to be very high strength right there. And for the deformation, again, there are little roll here, and that's about it. And the BluntCut MetalWorks heat treat of the Magnacut, also 62 Rockwell here. And you can see a little bit more deformation than the control. And so just like compared to the Aebl, for example, there are a lot of Aebl, a lot higher toughness, which also translates into a lower use strength. And so this Magnacut here, it looks like probably a little bit lower use strength, but going to be, I would consider it to be tougher. We will test push until the failure mode or fracture mode, but that's going to be in subsequent video perhaps. And 3V is 62, and all these blade, except for the control, I did additional heat treat sequences. So I get pretty much tray or ductility for strength. So a lot of, even compare this to the previous 3V, I mean video 3V, this is going to be smaller deformation now. But if we doing a lot, I'm going to do more, I mean the test with the more depth and cutting and then bigger impact, then that will show the higher toughness will show through, and it's probably going to fare better at that point. But that's for the next video. And the Venetis 4E, last video was 64 Rockwell, and it deformed a huge amount. But you can see here, out of 3 shots, except one here, they got pushed aside because again, the edge penetrate, and sometimes it's one they go steering mode, they get steer away, and they keep. And so that's why you do multiple, and you can see here this one hardly anything, and this one have very little. And compared to a Magnacut, for example, and you say, how come a 63 here? It seems to be more deformation. And I say, well, strength-wise, it's probably could be a little lower. So therefore, the hardness and use strength, it's not really aligned. And so, because at the peak hardness for Magnacut can be 65, for example, and my heat treat at Venadis 4E can be like 69. So how much you drop down, and again, I mean, because mount-side matrix max hardness about 69. So anyway, the damage that will show you, I mean, to doing really hard tasks like cutting nail or something, or bone or something, that will show. Anyway, Niolox, previous test, it's deformed a lot more, but this time it's less. But however, if you compare to the 2063 and the Aebl, you can see its behavior. So now the test would be, later on would be, the Niolox come closer to Aebl or 2063 or not. See, that is the thing, is it deformed. If it was brittle, then you will see it chip already. But however, you can see this 62 here compared to the previous video 62. This is a lot higher use strength. It's roll, or this case deformed a lot less. And Elmax, the same blade, except now previous video at 61 work well, now at 62.5, and you can see some area, and this thing look like actually is a nasty dent over on the other side. I mean, it seems to be jagged, but it's actually a dent, and then it pushed to the back side. And so you can see on this here is, I mean, virtually it just also slightly deflected to the back a little bit. And this one bent toward, I think, they all bent to the back. I think I have tendency to tilt my blade. But you can see how Elmax, even at this Rockwell here, and then the thing is, the use strength, they probably go toward the threshold, probably going to go fracture if the damage go up to this level. Maybe they go toward like 1 millimeter. It won't grow anymore. It's probably going to fracture or chip. And here is the zoom in of the median. That means out of the 3 cut, the one that not the best, not the worst, just the one or average down in the middle. And I will zoom in here. That's the S30V. 2063, 62 Rockwell. Aebl, you can see that, yep, they are the lower yield strength for sure. It deformed quite a bit. And Magnacut have some deformation there. That control, and this is this curve right here is just a bad grind. I was cutting the edge and I just eat it too much, or either that or there a little extra thickness or something here. But anyway, it have some deformation here, but not much. And 3V look pretty good. These are little white thing, and it just nail deposit, that's all. It's Venadis 4E is they have definitely some roll here. Some come going away from the screen and come toward this way. So in other words, the steering is pretty even, going both direction, in and out. And I kept it at this high hardness because that's why I project that the yield strength it closely matched to like something like Magnacut. So, and I think the wire projected toughness of Magnacut is for going to be higher. What I'm more to point out is Magnacut control heat treat. This is very impressive result because by just heat it up and go to the quenching and then liquid nitrogen and all shut and tempering, and this come out the default state pretty much, and able to do all this is the result is close to my optimized heat treat for other steel, and that is very impressive. I mean, so in other words, anybody can do this, and you get a result like this. It's just great. Niolox, well, again, in this case, it's zoom close in. Again, this thing is half a millimeter or so. Well, we'll see what it, the deformation for sure. We'll see what it can do when it cuts something larger than a 16D nail. Elmax look pretty good. Again, there's some of the dent here and some roll here, and some nail deposit still. Thanks for watching.